Hi children, welcome back to the session on a special session on special integrals. I hope you all had a very good time with the first session which I had posted on complete revision of indefinite integration, where we saw actually the core methods of integration, namely long division, substitution, integration by parts, that is the product rule, or you can say UV rule, right? So I hope you enjoyed that session. Now let us start our journey to the next leg and the last leg of indefinite integration. We are looking at special integrals. The beauty of this topic is very easy to understand. If the sum is given in specific forms, now for example, this is the chart B which talks about special integrals. Now in this special integrals you can see here by terms are there, dx upon by term, dx upon root by term, one set of sums. If the sum is based on these forms, you can directly apply these formulas. Similarly, based on these two forms, all these forms can be solved. I mean to say dx upon quadratic, root quadratic and so on. Now as I said, I am referring to your textbook exercise based on which I am taking one by one a couple of examples on each type, so that you get a first-hand experience of how really we do the sums if the sum is of that format, in that form. And most important is the exercise wise we will be solving a couple of examples from each type. So here there is a plenty of types. It looks vast, but definitely it doesn't last. I mean to say you can quickly finish off this particular thing. Very important, because this chart B, remember we had done in session 1, we did with chart A, core methods of integration. Here chart B deals with standard forms of integrants, standard forms. So all this type, all varieties we will be doing it. Like here you see by terms, quadratic, then numerator by term, this pattern, partial fractions, the special nature of sums like this. So everything we will be taking a couple of examples, and I think children, I bet that this lecture will be immensely beneficial for you all. Okay, so I really want you to catch up with that. Most important, don't watch it on mobile phone. Watch it on a bigger screen, laptop, desktop, 75mm screen, no problem. But remember one thing, the effectiveness of any lecture happens when you see on a bigger screen. So let us not waste time now. Let us start with this special integrals here, and as we go on, we'll see one by one all the different categories of sums in chart B. Let us begin. Now once again to go take the journey further on integration. Remember, the last leg of integration comes up specifically mentioning, not to forget it, it is nothing but special integrals. Special integrals. Now what I am trying to tell you is, look at this chart here quickly children, very interesting, simple also, with all this covered in one stroke. So it's very easy once you understand the technique, nothing looking back. But what are the patterns here? Every pattern we will cover up 1, 2 questions there and see how we go. It looks huge, but definitely students love this part of syllabus of integration more than the core methods of integration. So what we have to look upon. So let us see now quickly now children. Now the first thing which I want to share with you is this pattern here. Now this pattern, if you see, by term, by term, by term, by term, by term, by term, without root, with root. They are standard format. So whenever any sum is in this term, what is the standard format quickly children? Look, there is nothing in the numerator and the x square coefficient is 1. X square coefficient is 1. So without root, with root, the formulas are ready to be applied. So it's very easy, by term, by term, by term. Now all these things we will see as we go on. Let us see really how we go about this particular pattern of sum. So the first one, so before we proceed, remember As I said, I just want to share with you the standard formulas which is involved here. Okay, with, without root and with root. What are the formulas? Let us quickly go ahead with these formulas now. So I'm just putting across now. So dx upon integral dx upon x square plus a square is 1 by a tan inverse x by a plus c. So integral dx upon x square minus a square is 1 by 2a log of x minus a upon x plus a plus c. Integral dx upon a square minus x square is 1 by 2a log of a plus x upon a minus x plus c. Now first is what we are talking about. 15a exercise is basically based on by term, and of course this also, I mean to say a different pattern of sum here. Along with by term there is a different pattern of sum. So I want you to have a look at this. Okay, now I'll just come to the chart. So what we are going to do now here, look at this. I'll just put across. This part we are going to cover. So 15a, and this also is in 15a. 15a. Okay. So this part and this part. So what is this? Dx upon by term. Dx, not by term, if you see x raised to 4. We will come to that type of sum also. But understand, children, I really want you to regenerate yourself and then sit for the lecture, because this is a very, very important session which we are starting for special integrals. Standard formats of sum, just apply the formula, get the answer. That's why I want you to understand. So these are the two things which you are going to see now quickly. Now what we saw here. So by term. Now by term there is a condition to apply directly this formulas when only the sum belongs to this category. What is the sum pattern here? By term, two terms, and most important is nothing in the numerator, and x square coefficient is 1, 1 and 1. Then only I can apply the formula. Okay, so let us quickly do it now. So now if you see carefully here in this question, you know, I have a feeling here. Now carefully apply this. By term is there, nothing in the numerator, make me happy, but I can't apply this formula. Why I can't apply this formula, children? Because along with x square there is a coefficient 2, whereas in all this by term formula you have coefficient 1. So whenever there is another coefficient besides 1, you make it 1. How? What I am going to do is, I am going to look what I am doing. Okay, let's see, 50 plus 2x square. I want to eliminate this 2 and make it 1. So divide by 2 and I multiply by 2. This adjustment is specifically showing you in this question. So 1 upon 2 comes out here. 1 upon 2 integral this dx upon. Now look at this. What will happen? 50 upon 2 is 25 plus x square. So this I can say 1 upon 2 dx upon, this is nothing but 5 square plus x square. A square plus x square. So what is a square plus x square, or x square plus a square? 1 by a tan inverse. So this got converted in this format. So I can apply that formula here. So integral, I am just putting across, dx upon x square plus a square is 1 by a tan inverse x by a plus c. So what happens now? 1 by a. What is my a? 5. So 1 by 2 as it is. 1 by a tan inverse x by 5 plus c. So it is 1 by 10 tan inverse x by 5 plus c. Keep that in mind. That's the way it goes, that's the way it is done. Okay? I hope you got this point. So let's look at the next example. By term is there, I am happy about it. By term is there, but in the numerator something is there. So I can't apply this formula here. But by doing some basic thing I can try, okay, or cry. For example, suppose if I put x cube, let x cube as t. So what will happen now? 3x square dx will be dt. So x square dx will be 1 by 3 dt. Okay, so x square dx, see, technique I am using of substitution here to make this integrand look simple. So such type of adjustment you should know. So x square dx is 1 by 3 dt. So I am writing the 1 by 3 dt upon. Now pay attention here. You can write this as a3 square minus t square. Can I write like this? Right? So it is a square. This is my a now completely. A square minus x square. So a square minus x square, I have the formula that is 1 by 2a log of a plus x upon a minus x plus c. So be careful about it. It's a very standard format. Lot of sums we'll be doing on this by term. So not necessarily you have to do a lot of questions right now on this. So anyway, now coming to a point, what happened with the substitution? There is nothing in the numerator and t coefficient is 1. So x coefficient is 1, t coefficient is 1. That means I am ready to apply the formula. So 1 by 3. Okay, be careful now. So 1 by 2a. 2a cube, because my a is nothing but a cube, right? A is nothing but a cube. So a square minus x square. So 1 by 2a cube log of a plus x upon a minus x plus c. That's all. So what will happen now? This will become 1 upon 6a cube log of, this is a cube plus t, t is nothing but x cube upon a cube minus x cube plus c. So this is the final assault on this particular sum. So two cases, one directly you can do, but of course you have to eliminate this coefficient of x square. Similarly here there is no x square coefficient, right? But I can't say it belongs to this type right away. So what I did, I put, because x cube derivative is x square, so I just put x cube there. I was able to do this part very clearly. Okay, so that's the point. You have to remember these adjustments which are required for the by term. Okay, now this is very, very important now. So keep that in mind and have a look at this. So pause and note it down. By term, we'll see this situation again and again in many questions further. So just have a look at this. Pause and note it down. Okay, got it now guys? Let us take the next part. Now before I proceed to the next type, this is what by term is, just the formula keeps changing. X square plus a square 1 by a tan with x by a, just now mentioned. 1 by 2a log of x minus upon x plus a, 1 by 2a log of a plus x upon a minus. Now, I am not talking about this, I am talking about 15a, this and this. Now, what is the special type here? I want you to understand. There is x raised to 4 in the integrand. Okay, if the sum is of this format, you can apply the technique which I am showing you. Now, what is the technique? We will come to it when we do the question there. Okay, so very important. I would not say important because to the ISC point of view, its representation is very less in the papers, board papers, but it's a thing to be noted down because it doesn't come easily. The understanding is not that easy. What do we do this pattern here? So x square plus or minus a, x raised to 4. So x raised to 4 is there and x square is there. You apply, try to think about this pattern. Okay, I'll just take one example. You'll come to know. Look at this pattern here. X square plus 1, x raised to 4. Now, whenever you are in the integrand, see here you can't do long division. Why? Because degree is less than the degree of division. Second, substitution out of question. If you put x square as t, 2x, so what you have x square, substitution out of question. UV out of question. So no technique is being applied here. Can be applied. So what I am going to do is, before we proceed, when you see the sum of this pattern where square and x raised to 4 and everything exists, I just want you to keep one formula in mind. I'll just write the formula here. X square plus 1 by x square, I can write it as x plus 1 by x whole square minus 2 or x minus 1 by x whole square plus 2. A very exclusive type, I want you to pay attention. Okay. Now, so this I'll tell you when to use which formula for this term. That's a different story. Let us have a look at this, how I do the question there. Okay. Now, what I do in all these sums is, in all these sums, whenever you have this pattern of sum, you divide the numerator and denominator by x square. You divide the numerator and denominator by x square. So what happens now? If I do that, x square plus 1 upon x square the numerator, x4 plus 7x square plus 64 upon x square in the denominator. Now see what happens now, okay? This will become 1 plus 1 upon x square, so the x square goes to both of them. Now x square, this will become x square plus 7 plus 64 upon x square. I want you to be very careful now, okay? I want you to pay attention now. I am showing you directly the method here. Now once you have a category of this, remember what we are doing is 15A exercise sum, first exercise on by term and this term. Now once you finish with this, I want to be careful now. Look at this pattern. Now x square plus 1 upon x square. Now you just for the time being take the 7 this side. So what happens now? This will become 1 plus 1 upon x square. This is nothing but x square plus 64 upon x square plus 7. Okay. Now see this term, these two, x square plus 1 upon x square is this thing. Okay. Now listen. So if x square plus 1 upon, so this is suppose x square plus, this is becoming, now I want this to be the net result. Okay. So what happens now? Suppose if I say x square plus 64, look at this. So this, just put across like this. Say x square plus, what is that? 64 upon x square is equal to x plus, this is a perfect square, okay, keep that in mind. So 8 upon x whole square. Now, if I want this pattern, and now why I did minus 2 here? Because 2ab plus 2 minus 2 out this. So 2 8s are 16. If I have a square plus 64 upon x square plus 2 into a into b is plus 16. So I will do minus 16 now. Okay, minus 16 now. So this is what the working of this. So why I am doing this, I will just share with you quickly. Now I am trying to work out here. So this is becoming 1 plus 1 upon x square upon. Now x square plus 64 upon x square I can write in this format, x plus 8 upon x whole square minus 16 plus 7. Now I want to tell you which formula I am going to apply. Now remember this, in the beginning I shared with you these two formulas. Now I am not going to use this formula, I will tell you why, just a minute. Because see, both will give me x square plus 1 upon. If you open this up, you will get this. You open this up, you get this. So which formula you to apply? Now, why I am doing this, I will tell you. If you see this, x square plus 64 upon x square is there. I just now showed you that working of x square plus 64 by x square, right? If here it is plus, if here it is plus, you use the minus formula. So if I apply the formula, this will become x minus 8 upon x whole square minus 16, so it will become plus 16. Okay, because this will eventually be x square plus 64 upon x square. Okay, I hope you got this point clear. I am applying this formula, one of those. But as above is my plus, I use the minus formula. So this is x minus 8 upon x whole square plus 16. Because this will give me only these two terms. The plus 7 is left out, I write like this 7. Okay, just have a look at this particular pattern. Now once you finish with this, as a dx here, don't forget it. Now job is over. This is 1 plus 1 upon x square. This is nothing but x minus 8 upon x whole square plus root 23 whole square, because it is 23 square. Okay. So if you see this, this is my x now, this is my a. So don't you think this is x square plus a square formula? No, wait, don't jump the gun.
sorry, numerator is there. So what I can do, I have to use the technique. Let x minus 8 by x be t. If I put x minus 8 by x as t, what is derivative? Tell me. 1 minus there is a slight problem in this question. I want to confirm this question 1 minute. 1 second, children, just 1 second. Yeah, that's what the mistake happened here. It is not plus 1, it is minus plus 8. Okay, plus 8. Sorry, plus 8, plus 8. Okay, yeah, okay, plus 8 I got. Okay, fine, plus 8. So now what happens now? This will be, I put x minus 8, so x plus 1 plus, this will be 8 here, don't worry, plus 8 upon x squared dx will be dt. Now, idea of doing this is, when I use a substitution, I got adjusted the numerator. There is a numerator here, dx. So quickly, children, this will become dt upon the x minus 8 upon x is t. So t square plus root 23 whole square. Just have a look now, x square plus a square. So what is x square plus a? By term convert ho gaya nahi ho gaya? So that's what the idea of doing all this stuff is. Okay, I do understand. I hope this. I'll take one more question in the end. Okay, might be you understand this better. But please try to rewind this video again and again and look at the question. So this is x square plus a square formula. So 1 by a tan inverse t upon root 23 plus c. Now replace t. So this will become implies 1 by root 23 tan inverse t. What is my t here? X minus 8 upon x upon plus c. Okay, got the point. I want to simplify there, but I don't think anything is possible there except for LCM. So make a note of it. Remember what I did? I want to share with you. It is x square plus 8 upon. I did a difficult question right away. So I just divided by x square there. So I divided. I got this pattern here. This portion, this part, you have to use this formula. Okay. Now, because see, if you open this up now, you're going to get this only. So in place of this, I am using this. Now, whether to use the plus or minus sign inside. Plus is the outside is minus, minus the plus is outside. Why? When to do it? Look at the numerator is plus, then use the minus formula. If numerator is minus, use the plus formula. That's all. So once you do this, then you click x minus 8 upon x, the derivative is this. So I put this as t. So t square plus root 20 square. I think it's a wonderful game. And it gets converted to by term. Just now I saw how to do the formula for x square plus a square formula. I applied the formula and got it. Just have a look at it slightly running through this particular sum. I rushed to this sum, not a problem. Okay, next question. Oh God, 15b. Okay, great. So dx upon by term, please understand how to do this question. Come on, quickly. So I want you to have a really glimpse of this type here. Specifically, the first type is important for me, by term ka. If you understood this, this is important. The next part is 15b. Now, I just want to take to chart A, 15a. I think I will do that type of sum again. But before we proceed, so 15a is done here. So, the next part is this part. I can't find this part. Yeah, partial fraction. Yeah, this. After doing this 15a, this part is 15b. partial fraction. Okay, now this is an important one, 15b exercise, 15a, 15b exercise. Now partial fraction, I will take two questions, all category. Now in the partial fraction, what happens is, I don't mention, look at the partial fraction pattern. All these are very simple, okay, so don't get worked up. When the degree of the numerator is less than the degree of denominator and the denominator is in factor form. Now, if you remember, I told about the opposite. When the degree of the numerator is greater than the degree of denominator, then we did long division, core method. But in this it is reverse. Degree of the numerator is less than the degree of denominator and the denominator is in factor form. Now, there are three types. This is a linear factor. I can write like this. This is a repeated linear factor. X plus a is a linear factor but repeated twice. So that's why I can write in this format. This is not a linear factor, it's a quadratic factor. How I write like this? Just have a look at this. Non-repeated linear factor, repeated linear factor. Here it is quadratic factor. So this fraction I am writing as sum of two or more fractions. Okay. Just have a look at it. One of the category, one of the type will be there on that. I have taken all the three types for you all. You will understand it better. Okay. Let's take this pattern now. Okay, I hope you understood the pattern there. I'll just explain this when we come to the sum. Okay, now if you look at this, degree is 1. If I open it up, degree is 2. So degree of the numerator is less than the degree of denominator and the denominator is given in factor form. Now how I do this part, pay attention now. Degree of the denominator is given in factor form. How I do it? You write this, you don't solve this, you don't integrate this, okay, you write this in this form. Now, if you remember, I had given you the format of this was 1 upon x plus a into x plus b, because this is 1 and it's a factor format. So, this actually I write a upon x plus a plus b upon x plus b. So, this I can't integrate this, I have to write in this format and find the value of a and b. So, let me do it now for you. So what I'll do, I'll just write this pattern here, 2x plus 3 upon x plus 1 into x minus 3 is equal to, write the linear factor x plus 1, write the linear factor x minus 3, put a and b. Now I have to solve this out quickly. Now how I solve, remember you have to find, idea is to find a and b. Why? In place of this, you are going to write this, but with a and b value, because the integration this is very easier. Let me just see how. So if I find the LCM there, 2x plus 3 upon, this is x plus 1 into x minus 3. Look at the LCM there, x plus 1 into x minus 3. So this will become a into x minus 3 plus b into x plus 1. Now, if you look at both the sides, the denominator remains the same. You can equate the numerator. 2x plus 3 is equal to a into x minus 3 plus b into x plus 1. Now, once you finish with this, you have to find a and b value. Now, the question is how? Because you have to use this to integrate. Because if you solve this, you are going to get this. So, instead of using this, you use a simpler version of it, but with a and b value. How I find a and b? Very easy to understand. Whenever there is a linear factor, okay, I will tell you a shortcut method. I will put x equals to 3 because x minus 3. 3 minus 3 becomes 0, so a will go. So I put x equals to 3 in this equation. So what will happen now? These 2 3s are 6 plus 3 is equal to 0 plus 3 plus 1 4, 4b. So I think b is nothing but 9 upon 4. This part is important and interesting. Now I am going to put x as 3 I became. Now if you put x as minus 1, so minus 1 plus 1 becomes 0. So this will become minus 2 plus 3. This will become minus 4a. So a is nothing but minus 1 upon 4. So once I get a and b values, children, the sum falls down like 9 pins. So remember how I write this pattern. So this is the chart B, you can refer it once again. If it is linear, you write a upon x plus a with b upon x plus b. If it is x plus a whole square x plus b, then you write the factor of x plus a square. So x plus a square factor is x plus a, then again x plus a square is another factor, and then x plus b. In quadratic factor, you write in this format. So this is the pattern of sums for your syllabus. So once I find a and b, I have the job done, because I have to integrate this now. Integral a. What is a? Minus 1 upon 4 times x plus a, that is x plus 1, right? X plus 1, here a, x plus 1, right? Plus b. B is 9 upon 4 times, what is it? X plus b. X plus b is x minus 3. Now see how the integration is very easy for us to understand. What is the integration now? It is minus 1 by 4 log of x plus 1 plus 9 upon 4 log of x minus 3 plus c. Job is over. So this integration is this. Not a difficult case, but you have to understand. First is writing which format. It belongs to one of the 3 categories. Then after that, LCM simplified, you have to find a and b, that's the idea. Okay. So denominator same, equate the numerator. Now this finding a and b is crucial. Whenever the linear factor, if x is raised to power is 1, it becomes very easy to find the constant. Just put x equals to opposite there of this number, it becomes, this goes off. So in the end you have to solve and find the value of b. So if I put x equals to 3, 6 plus 3 is 9, this is 0, so 3 plus 1 is 4, so b is nothing but 9 upon 4. Now if I put a as x as minus 1, this will become 0, so minus 2 plus 3 is 1, and this is minus 4a, so a is minus. So take this and put here and integrate it, that's it. So integration is so cheaper. So let's take the next pattern. Now tell me, this belongs to what category? First one, second one, third one. Now let us have a look. X plus repeated linear factors. So x plus 1, repeated x plus a. It can be minus also here, don't worry about it, but only factor is repeated. So be careful now. How I write it on this, see. X plus a square factor is x plus a square factor is x plus a square, x plus b. Okay. Just see the pattern. Okay, now here we go. Sorry, it's not heavy there. So let us see quickly now how I do this. So 3x minus 2 upon this will be x plus 1 square into x plus 3. Okay, now what I suggest is first write the factors. X plus 1. Then x plus 1 square, and then x plus 3, because I want to share with you the constant. As it's a linear factor 1, it is a linear factor 1 a, linear factor, now linear factor 1 a, constant. When the quadratic factor, you write in this format ax plus b. So be careful about it. And I'll come back to that. Now see, the linear factor, so write A, linear factor, write B, linear factor, write C. Now once you finish with this, I told you what we did in the previous sum. After doing this, you did the LCM, basic mathematics, try to find the value of A, B and C. So let us see now. So 3x minus 2 upon, this is x plus 1 whole square, x plus 3, okay, is equal to, now LCM remains the same here, So x plus 1 whole square and x plus 3. Now what happens now, guys? So x plus 1. So look at the LCM pattern. A into x plus 1 is remaining, x plus 3 is, we compare it with the LCM, plus b into x plus 3 plus c into x plus 1 whole square. Now if you look at the denominators are equal on both the sides as the previous question, equate the numerators. 3x minus 2. Remember, in all the cases you have to find a, b and c. 3x minus 2 is equal to a into x plus 1 into x plus 3 plus b into x plus 3 plus c into x plus 1 whole square. Now, linear factor. Search for linear factor, because if you see the linear factor here, you can easily substitute something and get me the answer for that constant a, b, c which you are supposed to find. Now let us see what are the linear factors here. I can put x equals to minus 1, because minus 1 plus 1 becomes 0. So 3 into minus 1, minus 3 minus 2 is minus 5 is equal to, this is 0, this is 0. Now minus 1 plus 3 is 2b. So I directly get the answer as b as minus 5 upon 2. Any other linear factor is there? Yes, x plus 3. So now I can put x equals to minus 3, because this will become 0. So this will become minus 9 minus 2 is minus 11. This will become 0, this will become 0, because you are putting x as minus 3. This will become minus 3 plus 1. Now minus 3 plus 1 is minus 2. Minus 2 square is 4, 4c. So c is nothing but minus 11 upon 4. Very easy to understand. Then I go ahead with any other linear factor is there? No. My God, no. So once I get b and c, only one constant is left out, a, which you have to find. So whenever any one constant is left out to be found, whenever only one constant is left out to be found, then what I do is, I compare the constants on both the sides. Very easy to do. So comparing constants. Comparing constants. This is just a way of doing. You can put any value for x, form an equation a, b, c, take these values, find the a value. That's okay. But this is an easier way. Comparing constants on both sides. My idea is just to find a, b, c. What is the constant on the left hand side? Minus 2. What is the constant if I open up? Just see, 1 into 3, 3a, 3b and 1c. I already have b and c value. Put in this and try to find the value of a. So minus 2 is equal to 3a plus 3b. So minus 15 upon 2 plus c minus 11 upon 4. So the job will be 3a is minus 2 plus 15 upon 2 plus 11 upon 4. Find the LCM there. What is the LCM? 4 minus 8 plus 30 plus 11. I hope check the working children. Minus 30, that is plus 15 upon 2 plus 11 upon 4. LCM is 4 here. So 1 4s are 4, 4 2s are 8. 2 2s are 4, 2 2 15 the 30 plus 11. So how much it comes to? 30 minus 8 is 22. 22 33. 22 33 upon 4. So in short, 3a is 33 upon 4. So a is 11 upon 4. That's all. Once you get, I got b value, I got c value, I have to get a value. Now take this and put in this, because this sum I am writing in this format. So let us quickly do that. So a upon x plus 1. So integral 11 upon 4 of x plus 1 plus b. b is minus 5 upon 2 of x plus 1 whole square plus c. c is here minus 11 upon 4 x plus 3 dx. Believe me, if you simplify this, you are going to get the sum back. Okay, very simple now. 11 upon 4 log integral minus 11 upon 4, both are 11 upon 4. Oh, one with minus, okay. 11 upon 4 log x plus 3. Now look at this. Minus 5 by 2 I am writing as it is. Now this is 1 upon minus of 1 upon x plus 1 square. Whose derivative is 1 upon x derivative is minus 1 upon x square. This is minus 1 upon x plus 1 whole square. Derivative will be of 1 upon x plus 1. So plus 1 upon x plus 1. Understanding or not? See. 1 upon x derivative is minus 1 by x square. So what is integral minus 1 by x square? 1 by x. So similarly, 1 upon x plus 1 derivative is minus 1 upon x plus 1 square. Right? So here it is minus 1 upon x plus 1 square. So minus 1 upon x plus integration. Iska integration will be 1 upon x plus 1. So that's why. Or use the power rule. Take this up raised to minus 2. Apply the power rule. You will get the answer. Got the point clear, children? So this is the new pattern of question for partial fraction. Though it will belong to one of the type which I showed you, the 3 types. Okay, this is a repeated linear factor. How I write that fraction as a part fraction, that's important. That's understandable. Okay, that is important for you. Otherwise, this working remains the same as you did in the previous one. Okay, I hope you got this point clear, children. So pause and note it down. Slightly complicated, but worth doing this sum. So when we do this, I told you when we do this, look at this. Degree of the numerator is less than the degree of denominator, and the denominator in factor form. Look at the second example also. Degree of the numerator is 1. Here degree is, if I open up, it will be more than 1. Degree of the numerator is less than degree of denominator, and the denominator is given in fraction form, factor form. So not fraction form, sorry, factor form. And then you work out like that. Okay. Now pause and note it down, children. It's an important thing. The third type we will complete it right now. Just pay attention on that. Okay, let's take the next pattern now, quickly. Now, oh God, this is a quadratic factor. As I have mentioned before also, if you see, quadratic factors are there. So, quadratic factor, how you write it out? X square plus a, x square plus b. Write the factor here, x square plus a, x square plus b, and then numerator will be a. Very easy. This sum, in fact, more easier than the previous 2 category of partial fraction sum. Okay. So let us see this part here. Okay, guys. So simple working, much easier than that. So what I'll write, x square upon x square plus 1 into x square plus 4. Okay, is equal to, I told you first write the factor, x square plus 1, x square plus 4. Now as it is square, you will not write only one constant. If it is by 1 degree less, you write ax plus b. Basic logic is basic mathematics. Okay, so I am not explaining, I hope you know that. So ax plus b plus this is cx plus d, because when I divide x square by the quotient will be 1 degree less, so that's why I wrote that. So once you do that, I told you simplify it now. So this will become x square upon, this is x square plus 1 into x square plus 4 is equal to, this LCM is x square plus 1 into x square plus 4, and cross multiply now, ax plus b into x square plus 4 plus cx plus d into x square plus 1. Just LCM and cross multiply. Now very important steps I am going to explain to you. Now look at this, ax plus b into x square plus 4, because the denominator both sides is same, plus Cx plus d into x square plus 1. Now once you finish with this, children, pay attention. What you are supposed to do is, in the previous case what happened, if you see the linear factors, very easy to find a, b, c and all. But in this case it's not, there are no linear factors, there are quadratic factors are there. It's just not possible, okay, because square will always be positive, okay. Best is, the technique which I use is comparing coefficients. Because there is a equality, I am doing this, something very basic maths, okay, comparing coefficient. Now what I mean by this I will share with you. Okay, if I open up, see normally the method is what? Find ABC by hook or crook. If I open up, what is the maximum power you get? X into x square will be x cube. So normally they say open up and then do it. But I say that we are all mature enough, we can mentally work out that way, okay. Instead of opening, mentally you can just visualize and then do it. So x into x square. So what I suggest is, x cube is the maximum power, then x square, then x and then constant. Compare this coefficients on both the sides. Because there is an equality, whatever x cube will be the coefficient, the same x cube will be here. Whatever x square coefficient is 1, here also x square coefficient together it will be 1. So compare the coefficients, form an equation and solve them. Let us see. X cube, what is x cube here? 0. What is x cube if I open up? Ax into x square is ax cube. So a. Then there is no x cube. Cx plus c. Because cx into x square is c cube. X cube. Cx cube. Then compare x square. X square is 1. What is x square here? Ax, not possible. B. Plus, not possible. D. Because d into x square is d. Compare the x coefficient on both the sides. What is the x coefficient here? 0. Nothing. X coefficient, ax into 4, 4a. Plus, cx into 1, c. I think there is nothing much more. Then compare constant on both the sides. There is no constant here, 0. What is the constant here? Oh, not possible. B into 4, 4b. And d into 1, d. Now I want you to have a look. This is equation 1, equation 2, equation 3, equation 4. Now if you see equation 1 and 3, equation 2 and 4, you can solve them simultaneously and found. So first, solve 1 and 3. Solve 1 and 3 equation. So what you see? A plus C, A plus C. A is equal to what? Minus C. So A is minus C or C is equal to minus A. So 4A minus A. Now look at this, 4A minus A. Now you can see this here carefully there. So I think A and C will be 0. Check out. A plus C cube is square. Okay. Right. So I think A is minus C. So here I just want to see it's x square. Okay. Okay. So I think what happens here, 1 and 3 may, if I solve this, A is minus C. So A is minus C. So anyway, it is 0. So I think A is 0, C is also 0. Let us compare with B and D. So solve 2 and 4. Now if I solve 2 and 4, B plus D is 1, right? B plus D is 1, D is equal to minus 4B. So 1 is equal to, D is equal to minus 4B, D is minus 4B, so B minus 4B, so minus 3B, so B is equal to minus 1 by 3, B is minus 1 by 3, and here from here D is equal to minus 4B, so D will be equals to minus 4 into minus 1 by 3, D is equal to 4 by 3, okay. So I got all the values of A, B, C, D. Now place, instead of this, you are going to use this, right? So A is 0, B is nothing but minus 1 by 3 of x square plus 1, then C is 0, D is 4 by 3 of x square plus 4 dx. Now look, the integration, instead of this I am using this and solving it out. I just put the values back into this A, B, C, D and I got this. Now look at this integration, because if you solve this, you are going to get this part again. So instead of doing this, you solve this, integrate this. So very easy now, minus 1 by 3. What is integral dx upon x square plus 1? It is tan inverse x plus 4 by 3. X square plus a square. So 1 by a tan inverse x by a plus c. Okay, I hope you remember this. This is x square plus a square format by term. So what is x square plus dx upon x square plus square? 1 by a tan inverse x by a plus c. So I hope you got this point clear, children. So pause and note it down. So this is what is the partial fraction which I am trying to put across to you all. Okay. So we did this by term, we did 15a, this is 15b. So linear factor, repeated linear factor, how I write it, quadratic factor, how I write it. In the end you are finding a, b, c, d value and working out with this particular thing. So just observe it carefully there. So this is what it is, minus 1 by 3 tan inverse x plus 4 by, or you can say 2 by 3 tan inverse x by 2 plus c. So please understand this carefully there. 15b. Okay, 15b.
Okay children, I hope you enjoyed the session, you enjoyed the lecture dealing with partial fractions. I hope you remember all these things what we did. Let me take you back to chart B, where you will see happening good thing. Now for example, if I said 15a, I had covered over here this type by term without root, I mean to say by term without root, and of course this pattern. I will take a couple of examples later on this, not an issue at all. But at the same time, this time 15a we did, then 15b which deals all the three cases. I had done one question for your references. Remember partial fraction, when we use the case of partial fraction, when the degree of the numerator is less than the degree of the denominator and the denominator is in factor form. So then we use this. So either of this one type of category will be there. And I believe you should know how to deal and find the value of A, B, C. Now, having done this 15A, 15B, my next journey is 15C. So this is what is exactly in 15C. That is dx upon quadratic and linear upon quadratic. So I'll just match up with this now. So I believe this is nothing but 15C. Just to confirmation, I just want to do it after partial fraction. Just a minute, children. Yes, dx upon quadratic. So these two things is based on 15C. So what we look upon, how we do the sums based on this. Now remember these two points, one is dx upon by term without root, dx upon root by term. These two are very structured to deal with all these four types very easily. Even this also you can do by this using these forms, but I'll tell you how it is as we go on. So let us look at these questions now children. I'm talking now dx upon quadratic and linear upon quadratic. Okay, so I want everyone to pay attention now. So henceforth remember I'll be focusing and as and when the formula comes. Now dx upon quadratic. Now what is the main message I want to give you is, as we have the formula for the by terms, the same pattern, every sum we can convert into by term, the denominator, dx upon quadratic, dx upon quadratic. So let us see how we deal with it. Now first thing, remember in by term, everybody knows that just an example, dx upon x square plus a square we had, dx upon x square minus a square we had, dx upon a square minus x square also we had seen the sum based on this. So here children, if you see, there is nothing in the numerator, and most important is this x square coefficient is 1. So whenever you want to change anything into by term, remember you x square coefficient has to be 1. So first step is, whenever dx upon quadratic, check with the x square coefficient. Eliminate that x square coefficient. So here I am going ahead now. So what I am going to do is, dx upon, this will become 9x square plus 6x plus 1, divide by 9, because I want to eliminate this 9, and I multiply by 9. So what happens now quickly? 1 upon 9 dx upon, this will become x square plus 2 by 3x plus 1 by 9. Remember, there is a concept called completing the square method. What is the completing the square method? You add and subtract a term to this quadratic so that you can change it to a perfect square. Now that method is very simple. What I said, you add or subtract a term to make this term x square term as a perfect square. I mean to say this quadratic form as a perfect square. So how I deal with it, how I do it, I'll tell you. How you find that term which you have to add or subtract, children? How you find that term? There is a very good formula for a rescue: half into middle term whole square. This is the way of finding that term which you have to add to this x terms and subtract from the constant terms. So let us see that term now, how I do it. So what I do is half into middle term is 2 by 3 whole square. So it is nothing but 1 by 9. So I will add 1 by 9 and subtract 1 by 9. Of course, I can deal directly here. I'll just tell you, I'm just showing you a mechanism here, how we go about it. So that's why you should understand. So let us see this now. So 1 by 9 integral dx. What is the idea of doing this? I will share with you now. Remember, this is one set, okay? X square and x is one set and constant is another set. So add 1 by 9 to it. Of course, it's there. X square plus 2 by 3x plus 1 by 9. This term as it is, subtract 1 by 9. So of course this gets eliminated here. So you might ask me some question, some doubt. Now this goes, now this is a perfect square, this is a perfect square. This is x plus 1 by 3 whole square. X plus 1 by 3 whole square. Now please try to make a point here. You must say, if this gets eliminated directly, why here to add and subtract? This is a uniform procedure I am doing, because 99% sums will not land up into direct, because here itself I can directly write x the perfect square, 1 by 3 perfect square, whole square raised to 2 will give you this particular expression only. Instead of doing this plus 1 by 9 and minus 1 by 9, you can directly do. But I specifically insisted to understand this method, because 90% sums you don't get a situation like this. You have to add and subtract and then deal. So that's why let us maintain that uniformity. So quickly now, everybody knows what is the integration of course I did not change to by term here, the single term. Everybody knows what is the derivative of 1 upon x is minus 1 by x square. So this is nothing but 1 upon x plus 1 upon 3 square. So the integral of this is 1 by 9 minus 1 upon x plus 1 by 3 plus c. You can simplify this now. This will become 3x here, LCM, 3 1s are, 3 3s are. So eventually it will be minus 1 by 3. So I will just write it here, minus 1 by 3, 1 upon 3x plus 1 plus c. So this is my working here, okay? Keep that in mind. So this is what exactly the answer will look like. Just have a look at this sum, children. Okay, got it point? This is the way you deal with it. Now, let us take a situation here. Dx upon quadratic, dx upon quadratic. A very important message I want to give you is, wherever there is x square, here it is positive, here it is negative. Don't take negative common. There is no need to do it. Okay, why I will tell you. Now, I could not mention the purpose of adding and subtracting here, might be that will get clear over here. So, dx upon quadratic. Now, what I did, x square coefficient is 1. What I said, that the denominator I had to change it to by term or make it a perfect square. Here, this was itself, if I remove this 9, okay, if you remove this 9, then see here you can say 3x and 1 whole square. Directly you can get the answer. But I am just insisting that you follow the procedure. So here I want to convert by term. So what is the thing I did? You have to find this term, right? You have to find this term and then add and subtract. So let us see. So middle term. So I just believe half into middle term whole square is 1 by 4. Right? Half into middle term. Middle term is x term. Remember this. So as I said, if you see this pairing, I paired with the x and the constant. The same thing you have to do over here. So integral dx upon 1 plus 1 by 4 minus 1 by 4 plus x minus x square. So whenever the x square is negative, I added and subtracted right away over here 1 by 4, which I am supposed to do to make it a perfect square. How I do it? Let us see now. Now, what is the thing I want to share? This will be one pair. So, eventually, you can say dx upon, just see, this you take one pair. So, 4 plus 1, that is, you can say 5 by 4. This minus common, and this will be 1 by, or you can just write here, 1 by 4 minus x plus x square. Okay. Now, why I did this? Because this gets automatically changed to perfect square. How? So, integral, this will become dx upon root 5 upon 2 whole square minus, my attention here. Now, what you have to do, I will tell you here. This is the perfect square x, this is perfect square. So, x and 1 by 2. So, put x and put 1 by 2, put this minus sign and square. You solve this, you will get this. So, that's the idea of finding this middle term, that is half into middle term whole square formula, and finding that term which you have to add or subtract to make it a perfect square. Only one variation here, whenever the x square is positive, you add to this x square term and subtract from the constant. In this case, when it is the minus x square, then you add to the constant and subtract, ulta. Okay, nothing much difficult, 1 or 2 sums you practice at your end. I strongly believe you will get to know how to do that. So now, once you finish with this, what's the thing? Don't you think this is a square minus x square format? Dx upon a square. So what is the integral of dx upon a square minus x square is 1 by 2a log of a plus x upon a minus x plus c. I hope everybody remembers this formula just few minutes before I had solved the sums based on by terms. So this is my a now, this is my x. My job is over. So dx upon a square minus x square is 1 by 2a. So I believe the solution will be 1 by 2 into root 5 upon 2, 2a log of a plus x. This is my complete x, okay guys, x minus 1 by 2 upon a minus x plus c. Now after this I just have to simplify this now. So 2 gets eliminated here. If I find the LCM here, so what eventually it will end up to, it will be 1 upon root 5 log of, just see what happens guys, LCM will be 2x here. So you can say 2x plus root 5 minus 1 upon root 5 plus 1 minus 2x. Root 5 plus 1 minus 2x, right? Minus 2x. Sorry, I'll just have to work out with this now. Just a minute, children. So if you see this, what is happening here, if I find the LCM here, this will be root 5 minus 2x plus 1 plus c. So this is what exactly the answer will look upon. Okay, so So this is the answer of this particular question. So just have a look at this sum now. You can write anyway, either you write 2x first or whatever stuff it is. But what I wanted to do is to understand the mechanism of dx upon quadratic. This is what exactly we are doing in this now. If you see this chart here, dx upon quadratic convert into by term. Even dx upon root quadratic we change to that, but we'll come to that later on. Now we are talking about sums based on 15c. Once that category of sums are over, okay, from 15a, 15b, 15c, what is my suggestion is practice 4-5 sums from that particular exercise. So it becomes handy and that method registers in your mind. Okay, so I hope you got this point. The same thing we are going to do in many further formats of sum, so it's fine even though you have understood around 50 to 60% of it. Okay, now let us take another example now quickly. What happens and what is in store. Linear upon quadratic. This is what exactly the second case. Now remember, these sums are based on 15c. So dx upon quadratic and linear upon quadratic form. Okay, the working remains the same but slightly bigger sums in this, but much interesting. Now what we do whenever it is dx linear upon quadratic. So linear upon quadratic, what I do is I write the numerator as a into derivative of denominator plus b. Remember, in partial fraction a and b reminds me how I found the values of those constants a and b. On same lines you have to find a and b. So you find a and b in such a way with the derivative of denominator that you simplify this, you get the numerator back. So we don't use this numerator in the sum, we use this part of in the as a numerator. So let us quickly do it now. So numerator is equal to, I believe, numerator is equal to a into derivative of denominator. Why I am doing this I will tell you, plus b. Because once you I want to share with you why I do this. See, numerator you wrote like this, right? Numerator is a into derivative of denominator plus b. A and b are numbers. Upon this denominator you write it down and then give this d to both of them. So what will happen? This will become a dx plus b upon d denominator. So this is a easy, ax ho jayega. Then the denominator is quadratic. So dx upon quadratic. Just now you saw how to deal with dx upon quadratic format, right? So same way. So anyway, coming to a point, the same thing you're going to do. But as I said, first you find the value of a and b, without which there is no planner as such. So quickly, as I said, in this very easy, comparing the coefficient will be better option for me because there is no linear factor. Yes, there is a linear factor, but there is no need. So what I will do is, I will compare the coefficient of x. So just mention here, comparing coefficient of x and constant. Both process I am doing together. So compare the x coefficient now. So x implies what happens here, 2, LHS is 2, is equal to 2a. So there is no x coefficient here. There is a equality. So x coefficient on the left hand side will be same as x coefficient on the right hand side. So a will be equal to 1. Similarly, constant. Constant implies, what is the constant on the left hand side? 5. What is the constant here? Minus a plus b. Now just now I found a as 1. So minus 1 plus 5. So b is equal to 6. So I think my job is over here. So once I find a is equal to 1, b is equal to 6. Let us go ahead and write it down. So as I said, this numerator. So I am going with the sum now. Integral, numerator is a into. So 1 into 2x minus 1 plus 6 upon x square minus x minus 2 dx. Now what I did, I wrote this format. Now once I write in this format, I give this d to both of them. So what happens now, guys? If I give this to both of them, sorry, here I have to use log pattern here, not ax, okay? So anyway, now once you give it to both of them, let us see what happens now. So this will become integral integral 2x minus 1 upon x square minus x minus 2 dx plus 6 integral dx upon x square minus x minus 2. Now look at the two integrands here. Look at the two integrands, children. It is derivative of denominator f dash x upon, if you see this is nothing but f dash x upon fx form. This is dx upon quadratic, right? So you can deal with this very easily. This we had seen in core methods. So I will say let x square minus x minus 2 dt. So 2x minus 1 dx is equal to dt. So this got replaced here. So this will become what? 2x minus 1 dx is dt upon t, fine, plus 6 integral dx upon, now have a look at this, dx upon quadratic. What I did, dx upon quadratic, first x square coefficient 1 I change it to, and then add and subtract a term to make this a perfect square. So x square is 1, so half, let us find that term now quickly. So half into middle term, don't worry about the sign, whole square, answer is 1 by 4. So add 1 by 4, subtract 1 by 4. So what happens now, this will become x square minus x. Remember this is one set with x and this is another set constant. Add 1 by 4 minus 2, subtract 1 by 4. So I added this term and subtracted this term. As I said, once you finish with this, I think you can just pair it up like this with a minus sign common here. So this will become 2 plus 1 by 4. So with a constant and to the x term, you add and subtract. So once you finish with this, let us see. So here I have no issue. It is log t, right? Log t plus 6 times. Now pay attention now. If you look at this, I am not hurry to solve this out. Dx upon, now if you see this, why I do this addition subtraction, remember same thing I am going to explain again. This is a perfect square, x, this is a perfect square. So x 1 by 2, whatever the sign is there, put minus and this will become whole square. Believe me, open this up, you will get this. Then plus is minus, 4 2s are 8 plus 1, 9. So 3 upon 2 whole square. Don't you think it is reminding me x square minus a square format? So what is dx upon x square minus a square? So dx upon x square minus a square is 1 by 2a log of x minus a upon x plus a plus c. I think the standard form. So that's the idea of adding and subtracting term and converting into perfect square, because it gets converted to one of the bi-term formulas, that is dx upon quadratic. Now once you finish with this, I think I have to apply the formula. So I just replace this now here. So this will become log of x square minus x minus 2 plus 6 times. Now I am going to apply the formula here. 1 by 2a log of, now be careful, I just put a absolute sign, x minus a. So x minus 1 by 2 minus 3 by 2 upon plus a. That's it. Now I have to just simplify and see the game changer here. So what happens now, 2 gets cancelled, 3 2s are 6. Fine, now here if I find the LCM here, so whatever you can simplify, do the best of the simplification. Minus 2 plus 2 times log of. Now see what happens here, this will become 2x minus 4 upon 2x minus 4 upon 2x minus 4 upon 2x plus 2 plus c. You can take 2 common here and cancel that 2. You can do that simplification, okay. You can simplify that further, I have no objection. Just be comfortable in whatever you are doing. Oh, sorry. So I think this is better. Okay, look at the pattern of the answer. So, linear upon quadratic, understand the procedure. Linear upon quadratic goes on. This is not a sum, by the way, this is a continuation over here. From here, what we did, you gave it to both of them separate and then worked out the working. So, I hope you got this point clear. Children, remember, we are dealing with sums based on 15C. Just have a look at this, children. So, pause and note it down. Not difficult, it's interesting because it is achievable. Okay? So, just have a look at it first. So, I hope you understood how to do the sums based on dx upon quadratic and linear upon quadratic. Now, we see the next one. What is there in store? Let us see. Okay. Now, I think dx upon quadratic, linear upon quadratic, you know how it is. Linear is equal to a into derivative plus b on Shiva. You finished with this. Now, we will see the by term of this type. Dx upon root. Remember, you just saw few minutes back dx upon by term without root. Now, we will see the forms based on this. Same mechanism what you did for this and this, same mechanism for here also and here also, but with the root sign, the formula changes, the standard formula changes. So, let us see this part clearly. So, I want to just mention that to you. What is it exactly? That is called as integration of irrational numbers here. So, first what we are going to do is, we are going to deal with this now. So, this is nothing but 15D, okay. So, 15A, 15B, 15C and 15D, only this part, and then 15E will be this part, okay. So, interesting and simple. Let us see quickly now what we do. Now, before I proceed, I have to give you the formulas for that by terms now. What is that by term formula? Just see this. So, I want to put here, okay, I will write here, it's better. So, integral dx upon root of x square plus a square is log of x plus root of x square plus a square plus c. Similarly, dx upon root of x square minus a square is log of x plus root of x square minus a square plus c. Integral dx upon root of a square minus x square is sine inverse x by a plus c. So, these are the three things which I have told you all or showed you all in chart B, that is dx upon this pattern. So, the formulas are here. So, just take a note of it, make a note of it, children, so that we can start working with the question. So, once again, I want to take you back to the by term formula, but with root. What is the by term speciality? You can apply this form if and only if they are compulsorily in this format. Now, what is this format? By term, x square coefficient 1 and nothing in the numerator. Otherwise, you cannot do it. So, it has to be in this format, then only I can apply this formula. So, x square coefficient is 1, x square coefficient is 1, x square coefficient is 1. Nothing in the numerator, nothing in the numerator, nothing in the numerator. Then you apply this format. Now, let us have a look at this. Of course, by term is there with root. With root or without root, we saw both the formulas, right? With root, without root of by term, we had seen the sums before. So, now with root, but the problem is I cannot apply this any of this form. Of course, this x square minus a square. So, this pattern of sum, but the problem is this x square coefficient is 9. I told you when these type of sums are there, your x square coefficient has to be 1. Okay. So, what I am going to do is, I am going to divide by 9 and multiply by 9. Why? Because that x square will change. This square root 9 will go, it will become 1 upon 3. This dx upon, now just see what happens. 9 by 9 is x square here minus 5 by 3 whole square. This 9 I gave it to both of them.
So don't you think this became this format, that is integral dx upon root of x square minus a square format. So what is the formula for dx upon root of x square minus a square format? It is nothing but 1 by 3 as it is log of x plus root of x square minus a square 25 by 9 plus c. Now remember, in some sums what happens is the answer might not match because they have taken this constant out. How I will show you. So 1 by 3 they did this log of, I found the LCM there, upon square root 3. So this will become 3x plus square root of x square minus 25 upon 3 plus c. Now sometimes what happens in some answers, this 3 is taken off. Why? Because this will become log a minus log b. Log a upon b is log a minus log b. So the answer will be log a minus log b plus c. Now what the answer says in your textbook in some sum, this is a constant, this is a constant. So just ignore this constant because constant plus constant is a constant. So they just didn't write this and they just added this to be plus c, both the constants. So this is the final answer. You can keep it or you can keep it here also, still it's fine. But this is a better option for me and workable. So keep that in mind. So in fact, see, I am not teaching you anything new here. Whatever we did for dx upon by term, the process, the same thing, only the formula of this is changing. Right? Dx upon by term, the formula is different. Dx upon root by term is different formula. That's all. Otherwise, the procedure remains the same, making the x square coefficient 1 and then working on with that. Now here also, if you see, of course, here there is no root here. If you want, you can put a root here. So let's put a root so that you come to know exactly what I am talking about. Now, root. So even though it is x square plus a square, x is a big number here. So you can make it look simpler. Can I put let 2 minus x be t. So क्या हो जाएगा? So dx will be minus dt. So immediately what will happen, children? This will become dx is minus dt upon square root of, this will become t square plus 1 square. So I think x square plus a square. What is the formula for root of x square plus a square? Here this is the pattern. So here I want to share with you, this is nothing but dx upon root of x square plus a square format. So I can apply the formula now quickly. So this is minus 1 integral dt upon, what happens now? This is log of t plus square root of t square plus 1, because here the pattern is t and not x. Then replace t, what t stands for. So minus of, this will become log of 2 minus x plus 2 minus x whole square plus 1. So I think plus c. This is a simple way of looking at the questions here. That's the way you deal with dx upon root of by term. Remember, all the sums need to be done like this, but you have to ensure any format, children, any format, whether it's dx upon by term, dx upon quadratic, linear upon quadratic, linear upon water, or this, the x square coefficient should be, say, 1. X square coefficient should always be 1 in all this pattern. Otherwise, you cannot proceed. Okay, keep that in mind. So let us just take it out quickly now. Okay, yeah. So now, the next part. We saw dx upon root quadratic. Now we will see dx upon root quadratic. Now, dx upon root quadratic is 15e. So I just want to press my point here. So 15e. Remember, dx upon quadratic we saw, dx linear upon quadratic we saw. So dx upon root quadratic, linear upon quadratic, same procedure what we did in the previous part now, but root formulas are different, so that's why we have to deal with this. How? So let us quickly do it now. Root or without root, we have the formula. Stick to the procedure. Here x square coefficient is 2, so I will eliminate 2. divide by 2 and multiply by 2. So I believe I am directly doing here 1 upon root 2 integral dx upon, don't take the minus common, never do it. So this will become, if I divide this by 2, so this will become what now? 8 minus x square. Remember, I am dividing by 2 and multiplying by 2. I am dividing the denominator by 2 and multiplying the term by 2. So once you finish with this, 2 means it's root because it's inside the root sign, never forget it. I told you never take common. So now what I am going to do is, remember this constant is one set and this is another set. Okay, so keep that in mind. So now I just don't want to show you that. Now as I said, what I do, I make it a by term. How? By adding and subtracting a term. But whenever there is a minus sign, you add to the constant, subtract over here immediately. So let me just deal with it. So half into middle term whole square. Answer is 1 by 4. So let us deal with this now. So 1 by root 2 as it is, pay attention. This will be dx upon, okay. Now I am putting the root 8 plus 1 by 4 and as is minus sign, put minus 1 by 4 quickly, plus and minus both at the same time, minus x square, I copied down like this. Now if I take this minus common, this will become plus, this will become plus. This is a very important step, okay, keep that in mind. So now what happens now, let us simplify with basic mathematics. You will be surprised, after I do this procedure, this will get converted to by term. So 4 8s are 32, 32 plus 1 is 33. So I can say it is root 33 upon 2 whole square minus, okay. This is a perfect square, this is a perfect square here. So x, you first take this term, 1 by 2 and there is a plus sign over here, whole square. Open up, you will get this. Open up this, you get this. That's the beauty of this, that is half into middle term whole square. Now once you finish with this, but with a root sign, don't forget it. So this is a square, this is my a now, this complete is x. So don't you think this is square root of a square minus x square form. So what is the formula for square root of a square minus x square? Dx upon a square minus x square is sine inverse x by a plus c. So sine inverse 1 by root 2 is left out. I have to write down 1 by root 2 sine inverse x by a. Now what is my x here? This is my x plus 1 by 2 upon a. A is nothing but root 33 upon 2 plus c. So you can further simplify 1 upon root 2, 2x plus 1 upon root 33 plus c. Now I think the 2 gets cancelled there, right? So this is what exactly I am sharing with you. The procedure of for by terms remains the same, whether it's with root or without root, children. Just have patience and bear with it, because this is going to open up the complete topic understanding for you. Okay, remember this. So I hope you got this message clear. So 15E sums we are doing, dx upon quadratic. Just want to share with you and show you what we are talking about. Dx upon quadratic, root quadratic and linear upon. Here what we did for linear upon quadratic, you took the numerator as a into derivative of denominator plus b. So similarly here also same procedure. Okay, now this is based on I think 15E. Okay, so I just want to share with you this part is 15E. Just write it for your understanding, right, so that you come to know what pattern we are dealing with. Linear upon root quadratic. Now linear upon quadratic, the procedure remains the same, only the formula application in the end remains different. So anyway, linear upon quadratic, what I said, I write the numerator as a into derivative of denominator plus b. I want to be a good observer here. So the numerator is equal to a into derivative of, remember with root we have the formula. So the denominator you will consider only this inside part as the denominator. So a into derivative of this denominator here. So 2x plus 4 plus b. As I said, numerator you are writing in this format. So find a and b in such a way that it should be equal to 5x plus 3. So compare the coefficients here. X coefficient I will compare as I did in the previous sums. So x coefficient comparing 5 is equal to 2a. So a is 5 by 2. Then compare the constant, 3 is equal to 4a plus b. So 3 is equal to 4 into 5 by 2 plus b. 2 2s are 4, 5 2s are 10. So b is equal to minus 7. So I got a value, I got b value. Remember, I am writing the numerator in this format. So let us see now what happens. So numerator is equal to a. A is nothing but 5 by 2 times what? 2x plus 4 plus b, that is minus 7. If you simplify this, you get the numerator back. Upon, write the denominator as it is, x square plus 4x plus 10 dx. Simple there. I am totally engrossed in keeping on teaching. I hope you are understanding, you are following what I am putting across to you all children. Okay, remember every type we are covering, so just have patience and bear with it, because it is going to really open up your understanding of special integrals in a very, very dynamic way. Okay, so once you finish with this, I told you what I did in the previous dx upon quadratic, linear upon quadratic, you gave this to both of them. That's what exactly you are going to do. 5 upon 2, 2x plus 4 upon square root of x square plus 4x plus 10 dx plus minus 7 by the way, minus 7 integral dx upon square root of x square plus 4x plus 10. Now quickly children, this there is no problem, derivative function is there, derivative function is there, derivative is there. So here many ways you can deal with this question. So what I can do is, you can put this as I1 and this as I2, just to solve it separately so that you don't get messed up. So let us talk about I1 now. So I1 is 5 by 2 integral 2x plus 4 upon square root of x square plus 4x plus 10 dx. So what I'll do, I'll say let root of x square plus 4x plus 10 be t. So what will happen now? 1 upon 2 root x square plus 4x plus 10 into 2x plus 4 dx is equal to dt. Don't take common here. This 2 I can shift over here quickly and eliminate this 2 right away here. So what happens now? Just see the full integrand got adjusted. 2x plus 4 upon root of x square plus 4x plus 10 dx is 2 dt. 2x plus 4 upon square root of x square plus 4x plus 10 dx is 2 dt. So great now. So I think I1 is nothing but 5 by 2, right? Now what is happening? I am putting the integration sign, sorry. So 2x plus 4 upon this is 2 dt, 2 dt. So into 2 dt. So what is into 2 dt? This is 5 integral dt, it is 5t. Now 5t ka matlab, it is I1 is 5 root of x square plus 4x plus 10. So I1 I got this answer. Now I2 is very simple, everybody can do it because I2 is dx upon quadratic now. So let me just do this I2 quickly here. So I2 is integral minus 7 dx upon root of quadratic x square plus 4x plus 10. Now dx upon quadratic, just now you saw dx upon quadratic, you saw dx upon root quadratic. What I did? Same thing for dx upon quadratic but with a root sign. So half, so this is one term there. So I add and subtract a term. So half into middle term whole square. So it is nothing but 4. So let us do it quickly now. So I2 will be minus 7 integral dx upon root of, this is x square plus 4x plus 4 plus 10 minus 4. 1 plus 4 minus 4 I did, I pair it up, this will get converted to by term. So just see the beauty of this. So I2 is minus 7 integral dx upon, this will become x perfect square, 2 perfect square plus whole square plus root 6 whole square. So don't you think this has been changed to root of x square plus a square form, right? So what is the formula for root of x square plus a square form? I just now gave you dx upon x square plus a square log of x plus root of x square plus a square form. Okay, working is bigger but definitely not a difficult one. So I2 will be is equal to minus 7. So log of x is plus x square plus a square form is this part only. So if you want, you can simplify this, I know. So root of, okay, log of x plus root of this step as it is, x plus 2 whole square plus root 6 whole square. Remember, when you simplify this, you are going to get this quadratic back. So you can write this term over here. So I think I1 is ready for me. So similarly, I2 is also ready. So then the final answer is I1 plus I2. So number 1 and number 2. So adding 1 and 2, we will get the final answer. I did not end it. This is the solution. Okay, there is lot of space there. But linear upon quadratic, the same mechanism I am applying here. By term, very strong property, very strong formula. By term, dx upon by term, dx upon root by term. X square plus a square, x square minus a square minus a. Same formula for both. So beware, be clear and be understandable. So I hope you got this point, children. Remember, what we are doing is 15E, right? We are doing the sums on 15E, where it is dx upon root quadratic or linear upon root quadratic. The mechanism remains the same, with root, without root. Formula changes. So this is nothing but 15E. I hope you got this point clear. Just have a look at this clearly. Okay, I hope you got this point, children. So now what we are going to do is easy part now. It's not difficult. Now if you see carefully, I want you to just be a good observer for this chart. Remember, 15A was by term, this one and this pattern. Then 15B was partial fraction. 15C was dx upon quadratic, linear upon quadratic. 15D was dx upon by term. 15E was dx upon root quadratic, linear upon root quadratic. We have touched those questions now. Now important is by term only, but not in the denominator, in the numerator. So this is nothing but 15F. This is nothing but 15F. This part, all the procedure is same. This is the extension of this. So I think these two things is 15F. Here, this is 15F. And then this is a very easy thing now. This and this we will see, root quadratic. But there is no denominator. Here also there is a standard formula. So I will just put my point here. That is root of x square plus a square, root of x square minus a square, root of x square plus a square. Oh, sorry, here there is a slight change. This will be a square minus x square. Okay. So x square plus minus a square is a square minus x square. So how the things have to work out, let us see quickly now after this. So what we are going to do is 15F. Okay. We are going to deal with sum with 15F. Okay. Let us see this now. So root. So before I proceed, you need to know the formulas here. The formula is a little bit huge, but you can understand it, how to do it. I'll just write the formula here so that you can cover up this part. Just write the formula here. Okay. So what is the formula? First is integral root of x square plus a square. Okay, dx. See, there is no denominator, but by term in the numerator. So this is nothing but x by 2 root of x square plus a square by 2 log of x plus root of x square plus a square plus c. So, similarly, root of x square minus a square dx is equal to x by 2 root of x square minus a square by 2. Remember, when minus, it will be minus a square by 2 log of x plus root of x square minus a square plus c. Similarly, root of a square minus x square is x by 2 root of a square minus x square plus a square by 2 sine inverse x by a plus c. Have a look at this formula, children. Got it here? Right. Some textbook this is given a square plus x square, a square plus x square, a square. Doesn't make any difference, they are the same thing. So now, I missed out something here, 1 second, I think here we have to go. Now, look at this now. So, a square minus x square. So, there is by term, but not. But I want to share, see here also the same pattern, okay, because I want to explain this, 1 second. I just missed out something. Now, see here also if you see the coefficient is 1, the coefficient is 1, the coefficient is 1 here. So, keep that in mind, okay, by term with this. So, same mechanism, same formula only keeps changing. Now, let us see what dx root of, there is no by term. So, immediately I can do here, now look at this, this I can write as root of 2 square minus x square dx. So, everybody knows the formula a square minus x square. So, a square minus x square, what is the formula? X by 2. Now, how to remember this formula? Very easy. You know dx upon root is this formula. Dx upon this is this formula and dx upon this is this formula. So, this x by 2 copy this, x by 2 copy this, x by 2 copy this. So, formula learning is not difficult in this at all, just understand. Okay. So, what is this formula now? This is format is a square minus x square. Now, what is the a square minus x square? A square minus x square is x by 2 Om Namah Shivaya. So, let us quickly do it now. A square minus x square. Now, a square minus x square, everybody knows the formula now. What is the formula? If you want, I will just write down this. Remember, integral root of a square with root a square minus x square dx is x by 2 square root of a square minus x square, okay, plus a square by 2 sine inverse x by a plus c. So, I am applying the formula now. So, just see x by 2. What is x here? So, I think x by 2 as it is square root of same thing, that is 4 minus x square plus a square by 2, 4 by 2, a is 2, so 4 by 2 sine inverse x by a plus c. So, it becomes x by 2 square root, or no simplification required here except for some simple calculation or cancellation, to sine inverse x by 2 plus c. So, this is the way you deal with this question. Okay. Now, remember this sums based on 15f as I told you. Now, root quadratic. Now, what you did in dx upon quadratic, you added and subtracted to make it a perfect square. Similarly, here also you have to add and subtract a term to make it a perfect square. Same thing what you did in the previous part. But coefficient is 3. I have to divide by 3 and multiply by 3. So, I am just showing you here. So, this is 1 plus 2x minus 3x square. Remember, I am dividing by 3 and multiplying by root 3. So, what happens now quickly? See, this will be root 3, right? Root 3 integral, look at this. This is 1 by 3 plus 2 by 3x minus x square. I told you not to take common, not to take common. Now, what happens now? I told you, dx root quadratic, what I do? You just make it a perfect square by adding or subtracting a term. So, half into 2 by 3 whole square. Everything inside the root. 2 gets cancelled, 1 by 9. So this with x, this will be one pattern, the constant. So as it is a minus sign, I told you add and subtract right away. So this will become root 3 integral root 1 by 3 plus 1 by 9 minus 1 by 9. I told you whenever there is a minus x square, add and subtract that term which you find right away, and then just copy down these two things, 2 by 3x minus x square. So with the constant one pairing, minus outside, so this plus will become minus and this minus will become plus. So it becomes by term, and by term just now I showed you, by term without, in the numerator you have the formula here quickly, right? So look at this now, easy it is, not difficult. So root 3 integral, if I find the LCM here, LCM is 9, 3 plus 1, 2 by 3 whole square. Am I right here? Because LCM is 9, 3 3s are 9, 3 plus 1 4, 4 upon 9 is 2 by 3 whole square, minus, now pay attention, this is a perfect square, this is a perfect square, don't forget it. First write x here, so 1 by 3, 1 by 9 perfect, 1 by 3, put a minus sign here and put square. So I think it got changed to a square minus x square. So what is a square minus x square? Just now we saw, I think here only we saw a square minus x square, the formula remains the same. So what is the formula now? Let me do it, root 3 as it is. Now a square minus x square formula is what? X by 2. What is my x? This is my x. So x minus 1 by 3 by 2. Okay? Root of a square minus x square. Now please understand the formula, whatever it is, x by 2 root of a square minus x square is this thing only, or this thing, or this thing. You can write 1 plus 2x minus 3x square. Okay, a square minus x square, a square minus x square, the 3 will go off there, so that's why it just went off. Or you can write this a square minus x square, the same format. Because see, if you a square, if I open up, I get this. If you open up, you get this. If you open up, I think this you can write, or anyway, because that 3 will go up. If you want, you can do that part. So 1 plus 2x minus 3x square, say, upon 3. I don't want to write that because in the end the constant merges with constant. Okay, so I am not doing that at all now, for now. So a square minus x square, yeah, then what happens now? Plus what? A square by 2. What is a square by 2? 4 by 9 upon 2. This will become sine inverse x by a plus c. Now, I think I leave the simplification for you. Now, there is no need to, you can simplify this, there is no issue. You can simplify this, there is no issue. You can simplify this by LCM and finalize the answer. Okay, so I just write here, simplify further. Okay, there's a lot of space there, that's fine. But what is the point which I am telling you? Remember, for every pattern, okay, just want to share with you now. Look at this. Dx upon by term, we saw dx upon root by term. Dx upon by term, dx upon root by term, procedure same, and we just apply the different formula. Dx upon quadratic, we convert it to by term. Dx upon root we converted to by term. Linear upon quadratic, numerator is a into derivative of denominator plus b. Linear upon root quadratic, again same thing, a into derivative of denominator. Denominator means only the inside part plus b. Now here, by term, same procedure, but the formulas are different. Same procedure, formula different. Root quadratic, just now we saw, root quadratic again convert into by term by adding and subtracting a term. Now this is something, it was linear upon quadratic, but here is linear into. Procedure is simple, I will just explain to you how to do that. So this is what exactly we are looking at. This is the way you have to deal with the sum. Remember, we are dealing with 15F sum now, okay. This is also part of 15F, okay. 15F only, yeah, this is also part of. So I just want to this is also part of 15f only. Okay. So one sum, I'll just explain to you how to do that. But the formulas are slightly huge, but definitely it is understandable, doable. These sums are doable, unlike core methods. Now, linear into root quadratic. Whatever it is, simple it is, this numerator. Okay, this numerator, same thing what you did for linear upon root quadratic, you wrote this 2x minus 5 as a into denominator, inside part 2x minus 4 plus c plus b, right? A into derivative of this part, inside part plus inside part, remember. So actually I am writing, I just write down this, numerator is equal to a into derivative of this root form plus b, okay. Now I am writing that. Same thing what you did for dx linear upon quadratic. Now change, simple. So again now a will be 1, because if I compare the coefficient of x here, 2a, a is 1, compare the constant, minus 5 is equal to minus 4a plus b, so b is nothing but minus 1. So a is 1, b is minus 1, so I instead of this 2x minus 5 I write this. Now listen what I do. I want you to be a good observer, guys. Okay, now see. 2x minus 5, I write this. So a is 1 into 2x minus 4 plus b minus 1 into root quadratic. Huge sum, but we will do it. Now once you finish with this, I wrote a into the derivative minus b. Now this into this, open up this into this. So this will become 2x minus 4 into root of x square minus 4x plus 3 dx minus integral, minus into this. This is root of x square minus 4x plus 3 dx. Now look at this thing and what it reminds you, just see. What it reminds you? Just now we saw, na? Linear into quadratic, linear into root quadratic, just now we saw this type of sum. Oh, linear into quadratic, just now, just see doing this. Now, what is the thing? This is the derivative. So, don't you think this is f dash x into fx form? This f dash x into fx form, right? So, I will take this as I1, this is I1 and this is I2 and solve it out further. So, I1, so I think I will write this I1 here, 2x minus 4 into root of x square minus 4x plus 3 dx. So, I will put let root, don't put root, I think there is no need, put x square minus 4x plus 3 as t. So, 2x minus 4 dx will be equal to dt. So, come back here. So, this is I1 is equal to, just see 2x minus 4 dx became dt. So, this will become dt and this will become root t. So, t raised to half. So, the answer is t raised to 3 by 2 upon 3 by 2 plus c. Remember, is root t here, integral root t raised to half. So, power rule. So, this is 2 by 3 plus c, right. So, I just replace this t and that is I1. Now, let us get I2. What is I2 now? I2 is root quadratic, x square minus 4x plus 3 dx. I told you, whatever is the procedure, root quadratic, everything remains the same. Add and subtract and convert into by term, same thing you have to do here. So, half into 4. Middle term, it is nothing but 4. So, I2 will be is equal to, this is one term, this is another term. So, x square minus 4x, copy down, plus 4 plus 3 minus 4. So, with this group, big sum, can't help it, you can do it. So, but it is an interesting one, doable sum. So, I2 is nothing but root of, look at this will become x minus 2 whole square plus minus 1 whole square. So don't you think it is a square minus x square format? Yes. So what is x square minus a square? What is x square minus a square formula? This is the formula. So I2 will be eventually what? X by 2. This is my x now. Then square root of this. What is square root of this? This only. X square minus 4x plus 3 minus a square by 2. A is what? 1. 1 by 2. Log of x plus same thing. So you can write this as it is. X square minus 4x plus 3 plus 3. So I got I1, replace this t by the way, and I got I2. So adding, so I1 plus I2 will be the solution. Okay. Now if you feel how I got this, you can open this up or write this as it is, x square minus a square, write this as it is, plus log of x plus copied on this as it is. It will come as the same. Okay. Not a problem, but as I said, linear into root quadratic. So bi-term formulas which we started with in special integrals is really important. We have dx upon quadratic, dx upon root quadratic, dx upon bi-term formula, dx upon root bi-term formula, then dx upon quadratic convert into bi-term, dx upon root quadratic convert into bi-term, dx upon quadratic convert into bi-term, linear upon quadratic, numerator is equal to a into derivative of denominator plus b. Similarly, when bi-term appears in the numerator, again the formula is there, but the procedure remains the same. Again and again I am telling you, it looks huge, but it is doable. Understand what we are doing. I hope you got this point clear, children. Okay, so this is the pattern, this is the way you have to look upon this question. Just have a look at this sum quickly now. Remember, we had dealt with 15F properly and fully. Very few things left now. So I hope you got this point clear, children. So let us take the next part now. Now sums based on 15G. Now what is this pattern? I'll just share with you with the chart B. Now remember, 15F is complete, 15G. Now this part is 15G. Now in 15G is the last part of the integration, the last leg. Okay. What is the important pattern is, look at this pattern. If dx upon a plus b cos x sin x, or you have square also is available in this, that is if dx upon cos square x plus sin square x happens to be there, the procedure remains the same. Dx upon a plus b cos x sin x format or this pattern of sum, both. So 15 and this third one belongs to 15G. So remember what we do in this case, you put sin x as 2 tan x by 2 upon 1 plus tan square x by 2, or cos x as 1 minus tan square x by 2 upon 1 plus. Very specific procedure, okay? Nothing difficult it is. In this case, you would put numerator is equal to this portion. Remember, it's different than this part. Here it is a combination of sin x cos x with nothing in the numerator. Here a cos x plus b sin x c cos x, very easy. A into denominator plus b into derivative. Now this also I will explain you. Last leg of special integrals. I know you are very tired, but definitely I tell you it is worth viewing it. Okay. So let us have a look at this now. We can have a first pattern this. Whenever it is dx upon a plus b cos x sin x or combination of sin x cos x form, we apply this formula and then working is very easy, very easy. So let us see this sum clearly now. Okay. Last exercise 15G. Okay. Now what I said, whenever the sum is of this format, So dx upon a plus b sin x or cos x form, you put sin x as 2 tan x by 2 upon 1 plus tan square x by 2, half angle formula, and cos x as 1 minus tan square x by 2 upon 1 plus tan square x by 2. Procedure is very simple. Let us see both based on this pattern, a plus b sin x form, cos x form. There is a combination of sin and cos, no problem, you can do the same procedure. Even when you have a sin square, cos square, sin square, you have to do by this procedure only. So what is the pattern? Let us see and let us have a look at that. Very simple procedure, stick to it and understand it what I do. You put cos x as, do this part, so pay attention very clearly now, I am doing this. So this will become dx upon 4 minus 3, cos x as 1 minus tan square x by 2 upon 1 plus tan square x by 2 dx. Okay, once you finish with this. Once you apply this formula, you find the LCM here. Okay, LCM, simplify all the sums, this anyway. So I find the LCM here. So this will become dx upon 4 plus 4 tan square x by 2 minus 3 plus 3 tan square x by 2. Upon that 1 plus tan square, you can write here as sec square x by 2. Remember, the procedure is very simple. Okay. Now once you finish with this, just see what happens. I write it properly. Sec square x by 2 upon 4 plus 3, 7 tan square x by 2. 7 tan square, am I right here? Yes, 7 tan square x by 2, and 4 minus 3 is plus 1 dx. My job is over. Because once you finish with this, you have to go ahead with substitution only. Tan derivative is x square. So if I put tan x by 2 as t, so this will become sec square x by 2 dx. By chain rule, 1 by 2 will become 2 dt, because into 1 by 2 chain rule, the 2 goes up, so it will become 2 dt. So just see what happens now. This will become 2 dt upon 7t square plus 1 by term. So that's what the beauty of this. So I know what I'm going to do. I'm going to divide by 7 and multiply by 7. So this will become 2 upon 7 integral dt upon, this will become t square plus 1 upon root 7 whole square. So don't you think it is of this form, x square plus a square. What is x square plus a square? 1 by a tan inverse x by a plus c. So I am not rushing, okay. Remember, any sign you see, put this substitution, cos, you put this substitution and simplify. Basic maths will land up here somewhere. So I believe I am done with this now. So 2 by 7, I am writing, taking this into account now, children, here. So 2 by 7 as it is. So 1 by a, so 1 upon root 7, tan inverse t upon a 1 by root 7 plus c. I think you can simplify this. This will become 2 upon root 7, tan inverse root 7t, and replace and simplify. Replace means I mean to say resubstitute and simplify. I use the word wrong here. Resubstitute. Resubstitute for t. Okay, simplification is simple here, so there is lack of space there, I am sorry, but just work it out. Same lines here, there is cos and sin combined, same formula, same thing. So let us see now quickly what happens now. So I will just go ahead over here so that we can complete this sum properly. Dx upon 3, what cos x stands for? 1 minus tan square x by 2 upon 1 plus tan square x by 2 plus 4 2 tan x by 2 divided by 1 plus tan square x by 2 dx. So I applied it, whatever this part of substitution I am doing here. Now after substitution, what you did, you found the LCM same way over here. I have to go ahead with the LCM now. So what will happen now? Integral dx upon, now let us look at this. So this is 3 minus 3 tan square x by 2 plus 8 tan x by 2, and believe me that denominator is 1 plus tan square theta becomes sec square theta, it goes up. So this will become sec square x by 2 dx. Just have a look at that carefully and clearly. Okay, so once we finish with this, I think let us see what happens. Equal to, this will be sec square x by 2 dx upon, now this is a quadratic form with the minus sign, so I believe you can say 3 plus 8 tan x by 2 minus 3 tan square x by 2. So now same thing, now I put tan x by 2 as t, I put tan x by 2 as t. So what will happen now? Sec square x by 2 dx will be 2 dt. So quickly children, now this will become 2 dt upon 3 plus 8t minus 3t square. So dx upon quadratic. So dx upon quadratic, let us stick to the procedure, simple procedure it is. So divide by 3, multiply by 3. So what will happen now? Eventually 2 by 3 dt upon 1 plus 8 by 3t minus t square. So I told you it's a minus x square form, add and subtract a term. How I get the term? Let us quickly do it. So half into 8 by 3 whole square. So I think 2 4s are, so 16 by 9. So add and subtract 16 by 9 to this portion and to this, sorry, I believe this to this one and this one. But as it is minus, add and subtract right away. So let us see quickly now what happens now, which is equal to 2 by 3 dt upon 1 plus 16 by 9 minus 16 by 9 plus 8 by 3t minus t square. Remember what I did? 1 plus 16 by 9 I did, minus 16 by 9, and these two things I copied down here. Okay. Now I think this you can pair up, put the minus sign here, this will become plus and this will become minus. Now what happens now? Let us see. 2 by 3 dt upon, this is 5 by 3 whole square minus, this is t, this is 4 by 3 with a minus whole square. Now tell me what form it is. This is the form without root, of course, it is a square minus x square form. Now what is the formula for dx upon a square minus x square format? Whenever you have sine square and cos square, if you see this, for sin x you substitute. Remember, this is a linear format of trigonometry, so that's why I can do this. But whenever there is sine square or cos square, my suggestion is, remember, you can't do by any core method. You can't do substitution, you can't do UV, you can't do long division, no by term, nothing. So in such case, what I can do is, whenever you see cos square, sine square, divide the numerator and denominator by cos square x or sine square, but cos square is always preferred and understandable. So let us do that. So dividing numerator and denominator by cos square x. So what happens now? This is 1 upon cos square x upon 9 cos square x plus 8 sin square x plus 3 upon cos square x. Now this you do only when you have squares of trigonometric ratio, then you do it.
So do it now. So this will become 1 upon cos square becomes sec square x. Simple it is. 9 plus 8 tan square x plus 3 sec square x. Finished. My job is over. I can convert the tan derivative is x square. So convert this also to tan. So this will be sec square x upon, this will become 9 plus 8 tan square x plus 3 1 plus tan square x dx. Now you can simplify this out. Then tan x derivative is x square. So if I put, let tan x be t, so this will become sec square x dx will be dt. So sec square dx got adjusted, children. Simple it is, not difficult. So sec square x dx is dt. Now see 8t square plus 3t square, then 8t square plus 3t square plus 12. I hope it's working that way. 9 plus 3, 12, yeah, 8t square plus 3t square, okay. So what happens now here, this will become dt upon 11t square plus 12. So I think I am done here. Look at the question pattern here. Let me confirm that the sum is 9 cos square x. Yeah, I think let us see now. Okay, what happens now? 11t square, let me do this, divide by 11, multiply by 11. So 1 by 11 dt upon, this will be t square plus 12 upon 11 whole square. 12 upon 11 whole square. Okay, so let us do this now. So x square plus a square, don't you think this is x square plus a square format? What is integral dx upon x square plus a square? It is nothing but 1 by a tan inverse x by a plus c, right? So let us do that. So 1 by 11, 1 by a, so 1 upon 11 tan inverse x by a plus c. So this will become root 11, right? So this will get cancelled. So this is nothing but 1 upon root 132, then tan inverse, t is nothing but, look at this, t here is tan inverse of tan x, that is 11 root 11 tan x upon root 12, okay, plus c. Let me confirm it now quickly. 1 upon root 11 upon 12, that is tan x plus c. So this is the final answer for this particular question. So what I am trying to do is, I just made a pattern available for you right now. Sine square, cos square, you deal with these sums in this format. Okay, it's an important part, important lecture there, important understanding. There's one more small pattern of sum, last pattern I think so, for 15G. Just have a look at this question till then, children. Okay, let us see the next pattern of sum now. Last question. Wherever you have the sum of this pattern, a cos x plus b sin x upon c cos sin x plus d cos x, a sin and cos combination together. Remember, this is different than this sum, okay? This is different than this sum. Last part, okay? This is denominator dx upon a plus b. Now in that, numerator also has sin and cos. So in this case, one last part of the sum now, I really want you to have a look at it quickly. what we do is, in this case, now if you remember the chart which I shared with you, see, this pattern we finished, a plus b sin x cos x form. This we finished. This part, last part. What do you write? Numerator as a into denominator plus b into derivative of denominator. Very simple this is. I'll just tell you how to do that. Okay. Now look at this. What I said? Numerator is equal to. Okay. So numerator is equal to a into denominator plus b into derivative of denominator. Very exclusive type, simple working, but the method is very vague. So what I write? Numerator. So 3 cos x plus 2 sin x is equal to a into denominator. So a into denominator 4 sin x plus 5 cos x plus b into derivative of denominator. What is derivative of denominator? 4 cos x minus 5 sin x. Now find a and b, because you have to solve this and numerator you get. A very simple procedure. Now, of course, compare the sin x coefficient. What is the cos x? Cos x coefficient is 3, cos x coefficient is 5a, cos x coefficient is 4b, sin x coefficient is 2. Okay, I write here, so that compare cos x and sin x coefficients on both sides and solve for a and b. So I am doing that now. So sin x 2, so here it is 4a and minus 5b. Now you have to solve simultaneously. 3 cos x plus 2 sin x, 4 sin x plus 5 cos x. Now what you see here is the a value will be 23 upon 41. I am just solving this. A value will be 23 upon 41 and b value will be 2 upon 41. Can you solve this and try to find out it's right or wrong? Hurry up fast. Okay. Once you finish with this, then the working is very simple. Remember, this numerator should be written in this format, because if you simplify you get the numerator only. So integral a into denominator. What is denominator here? 4 sin x plus 5 cos x plus b. B is 2 upon 41 into here 4 cos x minus 5 sin x upon this denominator 4 sin x plus 5 cos x. My job is over, guys. What I did, I wrote the numerator as a into denominator plus b into derivative of denominator. This a and b are found in such a way that this will simplify and get the numerator. So instead of numerator, you wrote this portion with a and b values. So compare it, a and b has to be same now, 23 upon 20 over 41 and 2 upon 41. So once you finish with this, my job is over. It becomes very simple. If I give this to both of them, what will happen now? This will become 23 upon 41, this will cancel with this will become dx plus 2 upon 41, this will become 4 cos x minus 5 sin x upon 4 sin x plus 5 cos x dx. Job is over. It is integral is x, function is there, derivative is there, numerator is the derivative, so put the function as t, my job is over. So this will become 23 upon 41x plus
2 upon 41, I am writing this again so that we solve it properly. 4 cos x minus of 5 sin x upon 4 sin x plus 5 cos x. Now I think I can work out now. I'll put this as t quickly. So let 4 sin x plus 5 cos x as t. So this will become 4 cos x minus 5 sin x dx is dt. See, the numerator got adjusted. So what will happen now? This is 23 upon 41x plus 2 upon 41. This completely got adjusted dt upon t. Now what is integral dt upon t? Log t. So 23 upon 41x plus 2 upon 41 log t plus c. Now replace this. 23 upon 41x plus 2 upon 41 log of t is nothing but, what is t here? 4 sin x plus 5 cos x plus c. This is the final solution. So please understand, this is the last part of special integrals. We had covered each and every type. Please understand this, okay? Remember, we had covered everything from chart B. Just to share with you now, I'll explain, I'll take you back to that, don't worry. We had convert dx upon biterm, how to do, dx upon root biterm, how to do, dx upon quadratic, dx upon root quadratic, linear upon quadratic, linear, all is based on this. This also based on this, but the formulas are different for all, okay. Then this is a special pattern of sum which we had done, partial fraction we had done, and this is the last leg where dx upon a plus b cos x sin x or cos square sin square. Again I had covered this type of sums, and the last sum which we did for the session was this thing. So just to share with you, just have a look at the last question, children. I think it's not difficult, right? What we did, whenever you have sin and cos, keep that in mind. Whenever you have sin and cos, you write the numerator as a into denominator plus b. So you find a and b in such a way that you get the numerator back. So instead of writing the numerator after finding a and b, comparing the cos and sin x coefficient, just solving equation, that's all, okay. Solving equations, I get this value and I take this and put here in place of the numerator and give it to both of them. First is cancelling it, x, here substitution and solving. So I hope it's a long journey, but it is worth watching this because it covers every aspect of sum. So you keep the exercise, I referred the exercise, done 2-3 sums, do 2-3 sums from the exercise. Your integration, there is no scope that you will not be able to do. Special integrals, I agree, it's a long, lengthy topic, but it is worth because every sum is formatted. It is formulated, not formatted, formulated, and it's doable. That's what I wanted to share with you. So I hope you got this point clear, children, and in the end I want to say thank you to you because remember, you are my inspiration and always an encouragement for me, okay. So I will be coming up with good lectures now as we go on, but definitely integration is bound to be found difficult by the students. So both standard methods and this thing, very soon I will come out with definite integration and differential equation also, okay. So thank you very much once again for being with me, children. God bless you all and wish you all the best for the exam. I hope everybody understood what we did for standard method of integration and this thing that comes